Okay, we're on to lecture 16. Now, in this lecture, we're going to talk about really one specific kind of reaction, and that kind of reaction is called a precipitation reaction. So, really what that means is it's a reaction where two solutions, so when I say two solutions, that's like two containers that have stuff dissolved in them, like in water. Two solutions are mixed, and when they're mixed, they create a solid. To create a solid. Now, in chemistry land, when we say we make a solid like this, that solid is called a precipitate. A precipitate. So we're going to look at a few examples of this kind of reaction. It's a very common kind of reaction that we see in labs and so on. Now, before we get to that, we need to spend a little bit of time talking about, well, what kinds of things tend to dissolve in water and what kinds of things don't dissolve in water. And while we're at it, what happens exactly when we have something that is dissolving water? What does dissolving in water look like? All right, so that's what this video is going to be about. Like what happens when you dissolve, well, specifically an ionic compound in water. After we have a little more background on that, we'll be ready to talk about a precipitation reaction in the second and third part of this lecture. All right, so let me move on and we'll look at dissolving ionic compounds in water. All right, so a little background. So many times the chemicals we're reacting together are going to be chemicals dissolved in water. So again, we're going to kind of be thinking of like things that might happen in chemistry lab, but that's also true like everywhere, right? If we think about reactions going on in your body is mostly water. So when we think about reactions in living things, well, it's kind of the same idea. Those chemicals have been dissolved in water. Now, when we have things dissolved in water, mixtures of chemicals dissolved in water are called aqueous solutions. So when you dissolve chemicals in water, they're called aqueous solutions. What specifically is going to happen is water will separate the chemicals into individual molecules or ions. So water has this ability to break things up into individual ions. So let's look at a little example. So an example of this would be like if you just take good old table salt, right? Good old regular salt. When you put salt in water, so salt would be, table salt is NaCl. When we put that solid in water, and I'm just going to put like water above the arrow, what happens is the salt separates the positive sodiums away from the negative chlorides. So the positive and negative ions break apart. So when they are broken apart and when they're dissolved in water, we would say, well, they're not a solid anymore, it's dissolved. So this would be like, they're like aqueous now. That's the way we would call it in chemistry land. It's aqueous. So this diagram on the left is kind of showing you that process. So this would be sort of like a grain of salt, a little piece of salt. When you stick it in water, the sodiums, which would be the positive guys, like right here, they get carried off, surrounded by water. And then the negative guys, that would be kind of like the chlorides, they also get carried off and surrounded by water. So everything, all the little pieces in that salt crystal break apart, the positive and the negatives. Now, really what I want to focus in on is a little bit about how exactly this occurs. And there's a few details that are going to kind of become important when we look at reactions that kind of relate to this. So let's look at a couple more examples of writing out what happens when something dissolves in water. Okay, let's do that on another page. Let me flip over. All right, so let's look at a couple more compounds that are solids, and let's see what happens when they dissolve in water. So let's say, for example, I had some CaI2. Now Ca, oh, that's an A there. CaI2, that's actually, what would that be called? I guess calcium iodide. And calcium iodide is a solid. So, it doesn't look exactly like salt, but, kind of same idea. It's a solid. And let's imagine I take a little bit of it and I throw it into a beaker full of water. And I want to think about what's going to happen. Well, what's going to happen? Well, we can write out what's going to happen by writing out a little reaction. Calcium iodide, which is a solid, if you toss it into water, it's going to break apart. So the positive and the negatives are going to separate. So we would get calcium and we would get iodine. Now, there's a few details there that are kind of important and maybe not so obvious. So first off, when you break it apart, we want to show the charges, okay? So when they're together, they kind of cancel out, but when they're broken up, calcium, and you can look at your periodic table to confirm this, it's got a +2 charge. And iodine, when it breaks up, you can look at your periodic table to confirm this, it has a -1 charge, all right? So it breaks apart. So there's actually one more important detail, and that is not only are we separating the positive and negative charges, and we want to show that, we want to show how many we're getting. So let me get a piece of paper here and kind of show you. So our original compound, nope, I'm going to write it out here, is this. It's made up of, can you see that? Oh, I don't know if this is going to show up. Oh, yeah, it's made up of a calcium and 2 iodines. When you put it in water, all 3 of these separate from one another. So you're going to get the calcium broken up. It's going to go swimming around in the water. Bye-bye, I'm doing my thing. I'm swimming around in the water. But not only does that happen, the 2 iodines, they also separate from each other. So really what you're going to get in the water, you're going to have 3 things in the water. You're going to have the calcium piece, and you're going to have 2 iodine pieces. So the way I would show that in chemistry land is I don't just get a calcium and an iodine, I get a calcium and 2 iodines. So we put a 2 there, right? We get 2 of them. So in this beaker, there would be calcium floating around and 2 iodines. It should look like that. So we separate all of those apart from one another. All right. Oh, by the way, that's aqueous, isn't it? We write AQ. Now, let's do one more example. Let's say I put, I don't know, let's put another solid, one more. Maybe I should do it in another color. Lead, I guess this would be called lead nitrate, lead 2 nitrate. It's also a solid. It's like a white solid, looks a lot like salt. All right. And you put it in water. What are we going to get when we throw it in the water? All right, what are we going to get when we throw it in the water? Well, it's going to break up. When this thing breaks up, how does it break up? And what's it going to look like? Well, one thing I'm going to get when it breaks apart, we're going to separate the positives and the negatives. So the lead is going to separate. All right, and now one thing I should tell you, when we have a polyatomic, and I'm talking about the NO3, I'm talking about the nitrate here. When we have that polyatomic, yeah, it separates from the lead, but it doesn't separate any more than that. So the polyatomic, that group would stay together. We would have a lead, oh, wrong color, sorry. We would have a lead and we would get a nitrate as well, all right? So again, let me get my piece of paper. I don't know, good day for ripping up paper, why not? This is our original thing. And this is my original thing. Oh, can you see that? Oh, geez, the light. All right, there you go. That's my original thing. And it's going to fall apart in water. Mr. Lead goes flying off. Goodbye, I'm gone. I'm flying around in water. Goodbye, I'm doing my thing. And then, not only that, there's 2 nitrates. They are going to break apart from each other as well. To show that, how would I show that we actually get 2 nitrates? I would do that by putting a 2 right here. So just like before, we get a lead chunk and we get a nitrate chunk. Well, not just one of them though, we get 2 of them. All right, these pieces have charges, so you should write them out. So it should look like this. All right, it should look like that. And oh, they're dissolved in water, so we should write AQ. All right, so that's what it's going to look like. So that's a way of representing what's happening when you dissolve this in water. It's going to help us understand these reactions we're getting to in a few minutes. All right, so this is good. I love it. Good job. This is right. This is good job. I love it. Let me show you a couple of ways that sometimes I see students do this that are not so good. That way you know what to avoid. One thing, don't do this. When you write this out, when you think about this, don't write it this way. This is too bad, so sad, not right. So there's a 2 here. Sometimes people will do that. So if you write a subscript to 2, that's a problem, because if you have subscripts are showing me when things are connected. So what if you wrote it this bottom way, this way, there's a problem. You would be telling me the nitrates are still stuck to each other. That's what that means to a chemist, that the nitrates are stuck to each other. The NO2s are together. That's not true. They are individual. They have broken up from each other. So we get 2 independent pieces. If you do it this way, that's what you're telling me. Now, the other way that I don't want you to do it, because I don't want you to make a mistake on this, you might be tempted to write it like this. Oh, I wish I had a little more room. PB, and then you write like N, and then like O. Don't do that either. Again, the polyatomic, don't break up the polyatomic. Don't leave the NO3 as a thing. All right, I hope that makes sense. When we get to reactions, actually not in this lecture, it'll be in the next one. This will come up again, and then you'll see it again, and maybe it'll help you if you see it a little bit more. Okay, all right, let's move on. All right, so moving on. So ionic compounds, when they dissolve in water, they break up, they give you ions. All right, so let's move on. All right, well, it turns out not all ionic compounds dissolve in water. Not all ionic compounds dissolve in water. Only some things dissolve in water. Ionic compounds that dissolve in water are called soluble. Soluble means you dissolve in water. So the way that I show you that things dissolve in water is we say in a reaction, you might see like an AQ. An AQ, oh, there's supposed to be a Q there. An AQ means that this is something that's dissolved in water. Now, there's some ionic compounds that do not dissolve in water. Ionic compounds that don't dissolve in water, those are called insoluble. And there's a little symbol for those you might see in a reaction. Things that don't dissolve in water, so if you don't dissolve in water, what does that mean? It means you stay as a solid, or you are a solid. So what I would show in a reaction, if you don't dissolve, that's another way of saying you stay together. That's another way of saying you're a solid. You'll see an S. All right, so what we're going to need to be able to understand to write out this next kind of reaction is we're going to need to be able to decide, are you a thing that dissolves, or are you a thing that doesn't dissolve? And there's some rules that help us understand that. So let's get to how can we tell, are you a thing that dissolves in water? I was just saying, how can we tell if you're dissolved in water or you're something that doesn't dissolve in water? There might have been a little glitch in the video there. All right, so let's see. So the way we can tell if an ionic compound is going to dissolve in water or not, there's rules. And the rules have to depend on what ions are in the compound. So there's 6 rules here, I suppose. Yeah, there's 6 of them. And just to make it a little easier, maybe I'll go ahead and number them. Rule 1, Rule 2, Rule 3, Rule 4, Rule 5, and Rule 6. So, sorry. These rules say when we look at a formula, if you see in the formula, for example, you see lithium or sodium or potassium or ammonium, anything that has that as part of its makeup, they always dissolve in water. They're always soluble. There's never an exception. So if you contain lithium, sodium, potassium, or ammonium, you always dissolve in water. There's another rule. It says, well, if you contain nitrate or acetate, you always dissolve in water. Never an exception to that rule. Anything that has nitrate, or the second one there, that's called acetate. If you are part of the makeup of something, you dissolve in water. All right, next rule. If you contain chloride, bromide, and iodine, you dissolve in water. There's some exceptions to that though. If you happen to contain also silver or mercury and lead, you don't dissolve in water. So this rule has an exception. Most things that have chloride, bromide, and iodine will dissolve, but not if you have, for example, silver chloride. No, no, no. Not if you have, for example, silver bromide. No, no, no. Or, I don't know, like lead iodide. No, no, no. That's not going to dissolve either. All right, so if you have one of those exceptions, you wouldn't dissolve if you happen to contain one of these three in addition. Okay, there is a fourth rule. Fourth rule says if you got sulfate, you will dissolve unless you happen to be barium sulfate, calcium sulfate, strontium sulfate, or lead sulfate. You won't, all right? So most things with sulfate will, but there are some exceptions if you also see lead or barium or calcium or strontium. All right, now there's a second section, rules 5 and 6. Now this can be a little confusing. The rules at the bottom tell you about things that don't dissolve. If you have hydroxide, you won't dissolve. If you have sulfide, you won't dissolve. If you have carbonate, you won't dissolve. If you have phosphate, you won't dissolve. But then there's some exceptions. For example, things with carbonate don't dissolve unless they have lead. It's an exception. So you don't dissolve. So if you have lithium, you don't dissolve. What does that mean? Oh, it means you would dissolve. So things with carbonate don't dissolve, but if they have these, they break that rule. They actually would dissolve. All right, the same thing's true with the other rules. All right, so with this little introduction, let's see, it might make more sense if we just do some examples. I'm going to erase this. That's to clean it up a little bit. And let's look at a few. So the goal again, these rules tell us, are you a fella who dissolves in water, or are you a fella who doesn't dissolve in water? All right, so let's look at, I'm going to do a few examples here. All right, let me put up a couple examples. Let's say if I asked you, and maybe I'll put them at the bottom. What if I asked you about this compound, lead nitrate? Dissolve or not dissolve? Let's think about that one. While we're at it, how about sodium chloride? Dissolve or don't dissolve? And what about, let's do silver iodide? Dissolve or don't dissolve? All right. Do these things dissolve in water or not? All right. Go through them one by one. Lead nitrate. So I need to find a rule that has something to do with this compound. And the one that seems the most likely is there is a rule for nitrate. And the rule says, so you look down the list on the left for something that you see in the formula, and I see there's a rule for nitrate, and the rule says anybody with nitrate is soluble. There is never ever an exception. If you got nitrate, you dissolve. So what symbol would we use in our reaction? If you dissolve, I'm going to call this thing AQ. It's aqueous. All right, it dissolves in water. All right, let's do the next one. Sodium chloride. You got to find a rule that has to do with sodium or chloride. And in fact, there's actually two rules would get the same answer. So I could look at either rule 1, which tells me about sodium, or I could even look at rule 3, which has to do with chloride. If you use this either rule, you'll get the same answer. Let's just go with rule 1. Rule 1 says, if you got sodium in you, you dissolve. Never an exception. This thing is aqueous. That is probably not shocking. Salt dissolves in water, doesn't it? Okay, another one. Another one. Silver iodide. I need to find a rule that has to do with silver or iodide. Let me erase a little bit of this. It's getting messy. All right, so silver or iodide. All right, do you see a rule that has to do with silver iodide? I see one. It's rule number 3. Rule number 3 tells me about what iodide does. If you got iodide, you dissolve. Wait a minute, though. There's an exception. Not if you also have silver in you. If you have silver in you, you are an exception. You don't dissolve. So what symbol do we use for that? Oh, that's a solid. We use the symbol solid. All right, so we need a little practice using these rules. Let me put up a few more for you to think about, all right? And maybe we'll do one more together here. Let me see, I got 3 examples. I want to think about what order would make the most sense. Let's do this one. All right, we're gonna do this one first. All right, I'm gonna take a little breather first, just a second. Dissolve or don't dissolve. You could pause this if you want to think about it. And then after this, we might do a couple of like some pop-up questions, but let's just try one more. Maybe you should think about this. Dissolve or don't dissolve. All right, I hope you thought about it. All right, so first off, what rule is going to help me? There is a rule that has to do with sulfide. Things with sulfide don't dissolve. There are some exceptions. Lithium and sodium, potassium, ammonium. Lithium sulfide would, sodium sulfide would, potassium sulfide would, ammonium sulfide would. This is not an exception. So, sulfides don't dissolve, and there are some exceptions. This ain't one of them. If you don't dissolve, what does that mean? Solid or aqueous? You don't dissolve, this thing is a solid. This thing is a solid. All right. With that, I'm going to put up a couple. These are going to be pop-up questions, so they'll pop up in a minute here. What about this fella? Dissolve or don't dissolve? Lithium carbonate. Does it dissolve in water or not? And while we're at it, let's do copper. We're going to do, oh, I might change my mind here. Let's do copper sulfate. Copper sulfate. All right, those two. What do you think? All right, lithium carbonate. This one, we'll do a little pop-up question here. Lithium carbonate, dissolve or don't dissolve? All right, I hope for that one you said, well, I find a rule for lithium. Things with lithium always dissolve. They're always soluble. So it would dissolve in water. What's the symbol for dissolving water? AQ. You're aqueous. Rule number 1. All right, pop-up question number 2. Copper sulfate. Dissolve or don't dissolve? Oh, let's see. So, copper sulfate. There is a rule for sulfate. Things with sulfate dissolve. There are some exceptions. This is not one of them. So this thing is also aqueous. They're both aqueous. All right. So again, we're going to get some more practice or use these rules when we start writing out reactions in a little bit. Okay. So as we kind of wind this up, let me just mention a couple of things here. And that is that when we think about things that don't dissolve, ionic compounds that don't dissolve, those are basically rocks. All right. So most ionic compounds, if they don't dissolve in water, that means that they're like something that will stick around even when it rains. So like, for example, a lot of these tend to be like minerals or rocks. So I think a minute ago, I did as an example iron sulfide. And we figured out that guy is a solid. It doesn't dissolve. Iron sulfide, yeah, that's the chemistry name for it. And if you're taking geology, they would actually call that iron pyrite. That's fool's gold, okay? So for example, that's a solid that doesn't dissolve in water. So some ionic compounds dissolve in water. Those are called aqueous. Things that don't dissolve in water are going to be solids in water. All right, with that, let's move on to how this applies to reactions. That'll be coming up in the next part of this video.